Consider the infinite sequence A1, comma, A2, comma, A3, comma, all the way through AI, some indeterminate term. Sometimes we use AN for that. Dot, 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 dot. It's going on forever. The sum of the first n terms is a finite series or a partial sum. I'm taking the sum, so therefore I'm talking about a series now. I'm shifting away from commas between the terms and into plus. I'm doing A1 plus A2 plus A3 plus all the way up to some AN, and then critically, I'm saying stop. And if we do stop, then we have what's known as a finite series. Now, how could I write this using summation notation? The sum of, this is the general term, AI, sometimes we use AN, of I equals 1 to some undetermined n, and we're stopping there. When we're considering this infinite sequence, A1, comma, A2, comma, A3, comma, dot, 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 AI, dot, 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 the sum of all of the terms of the infinite sequence is called the infinite series. No longer is it called the finite series or the partial series or the partial sum. That's what we had before. If we're going on forever, I'm taking these commas of the sequence and I'm now putting in pluses. I'm adding them up. So in summation or sigma notation, I'm going from A equals 1 as my lower limit. This is critical. My new upper limit is infinity, and there is my general term. Here's an example. For the series, lower limit 1 to upper limit infinity. So I know it's an infinite series. Why do I know it's a series? Because this summation notation says I'm going to add the terms. Here's my general term. This is A sub I or A sub n if we were using n's. 3 over 10 to the I power. Notice, index is I, so I'm good. I can plug in for I, in other words. Find the third partial sum. Well, what does that mean? I'm going to plug in a 1. So that's going to be 3 over 10 to the 1 plus 3 over 10 to the 2 plus 3 over 10 to the 3. I found 3 terms. That's what that third partial sum means to me. Well, this is 3 over 10, or 0.3. This is 3 over 100, which is 0.03. And this is 3 over 1,000, 10 times 10 times 10, which is 0.003. When I add those together, I get 0.333. For this series, where our lower limit is 1, our upper limit is infinity of 3 over 10 to the I, find the sum of the series. Now I have infinite terms. Of course, this is 3 over 10 to the 1 plus 3 over 10 squared plus 3 over 10 to the third plus 3 over 10 to the fourth plus 3 over 10 to the fifth, and plus that will go on forever and ever, which will be 3 over 10 plus 3 over 100 plus 3 over 1,000 plus 3 over 10,000 plus 3 over 100,000, and on we go, plus dot, 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 which gives us 0.3 plus 0.03 plus 0.003 plus 0.0003 plus 0.00003, which of course will be 0.33333, etc., which gives us exactly 1/3.